Hi, I'm Thomas from Neuzeit Instruments, and this is Drop, a new MIDI control center for playing electronic music live. I've been playing live sets for more than 14 years now, and over time I have encountered many challenges, some of them over and over again, which is why I developed Drop as kind of a problem solver. And if you're also into live electronic music, chances are you have had similar experiences, and I hope that Drop can serve as a missing piece for you as well. So it's way more than just a MIDI controller, and we have a lot to cover, so let's dive in. Drop comes with adapters and cables, as well as a power supply with 4 international adapters. These should cover most countries around the world. You can also power Drop through its USB 1 port. This allows you to connect it to a computer via USB only and use it as a standard MIDI controller right away. Please note that the USB host must have a USB-C connector that can deliver at least 1500 mA at 5 volts to power the device. This applies to most USB-C ports that computers have nowadays. However, the older USB-A sockets will not work for powering Drop, even if it can supply enough power. If only USB-A is available, use Drop's power supply. Before you start, it's worth downloading the latest firmware to your Drop. First, save your project if you haven't already done so. Now visit our website and download the latest firmware. Copy the file to the firmwares folder on Drop's SD card. Then insert the SD card back into the back of Drop. Turn off the device, and when turning it back on, hold down the Shift key until the display shows bootloader. Here you will see the contents of the firmware folder and can select the new firmware and start the update by pressing the encoder. It usually takes less than a minute. You can then exit the bootloader using the Leave button and return to normal operation, or simply switch Drop off and on again. And don't worry if you lose power during the update. Nothing can go wrong here, just try again. The first time you turn on Drop, it will look like this and be set up to be used with a DAW. Although you can customize Drop extensively, you can easily restore the initial settings by going to Menu, Project, DAW Init. This will override your current project with a basic initialization so that Drop behaves like a regular MIDI controller. If you want to use Drop with a hardware-based setup, do not start with the DAW Init. Use Clean Init instead. This removes all mappings on Drop, giving you a blank canvas to start with, which I highly recommend when using hardware gear. You can save your current project, load another one, rename or delete projects, or clean up a cluttered project using the Purge function. All projects are saved in a human-readable JSON format on Drop's internal SD card. So there is basically no limitation to the number of projects, and you can easily back up the card on your computer before going on stage. There are only a few things to do when entering the DAW Init menu. Specify one of the 8 internal device IDs and the input and output hardware port to which you want to connect your DAW. You can also set color schemes here. If Quick Turn is deactivated, pushing the encoders can be used as another MIDI button. Otherwise, pushing the encoder simply makes rotation go faster. DAW Init only provides a starting point. You can also customize this later. Once you confirm, you can connect Drop to your DAW as you would with any other MIDI controller. You will see it listed as a MIDI device in your DAW. There is no driver installation necessary as Drop is class compliant. In Ableton, simply select all the checkmarks. The mapping process is the same as with any other MIDI controller. Enter your DAW's Learn mode, move the control element, and the assignment will be listed in the DAW. Also, applying curves or min and max ranges should be done in the DAW. I exit mapping mode, and now the mapped software control elements react to movement on drop. Vice versa, when moving the control element in the DAW, also the controls on drop change. It's called MIDI feedback. The faders are a bit special. They are not motorized, but the arrow-shaped LEDs show you in which direction you need to move the fader to pick up the internal value. This has nothing to do with Ableton's takeover mode. Instead, this is something that Drop does all by itself. If you are already familiar with Drop and have a hybrid setup using multiple mapping slots, here is a pro tip. If you want to send only the MIDI data of a single slot, open the mapping menu on Drop, select the slot, and hold Shift while moving the control element. Only the currently selected slot sends out MIDI then, so it is easier to map. We currently offer Bitwig and Ableton Live scripts for download on our website. This allows you to use Drop as a clip launcher. The Bitwig script is also necessary for proper LED feedback, and it is included natively with Bitwig version 6 and higher. If you are using Bitwig version 5, drag and drop the file onto the Bitwig application window or manually move it into the extensions folder. For Ableton, choose the appropriate script version and move the extracted folder into the remote scripts directory. You may need to create that folder first. We also gave the scripts a version number, so Drop will show up as Drop version 1 in Ableton. In Bitwig, Drop is automatically detected. Set Drop as the master clock by enabling here and here. When I push play on Drop, Bitwig starts playback, and pushing Shift and play stops playback. The tempo can be set on Drop by pushing the Shift and clock button simultaneously. If Bitwig should act as the master clock, change the source to Ext MIDI and select the DAW device. Then in Bitwig, this button must be off, and make sure that Bitwig also sends the clock to Drop. That way, Bitwig is the master clock now. Once Drop is connected to the computer, select Drop as the input and output device for the script. To enable the mapping, simply check all the boxes. To use Drop as the master clock, make sure that the Ext button in Ableton is on and that Drop's clock is set to internal. If Ableton should be the master, set Drop's clock to Ext MIDI. The Clip Launcher works quite similar in Ableton and Bitwig. To use it, push Shift and the Grid button. The upper 4x4 buttons represent the clips with their respective colors. Simply push the button to start and stop the clip. When a clip is playing, the button blinks. You can move the grid using the blue buttons. Bitwig also has this amazing arranger view where the grid is flipped by 90 degrees. The lower button row stops the clip in the corresponding column. When holding Shift, the small white button stops all the clips, but does not stop the clock. The green column lets you fire an entire scene. The red column also fires a scene, but it waits with firing until Drop's playback reaches the top of the circle. This is when the current cycle of 8 bars ends and the next one starts. And it is also the same timing like firing a snapshot in drop mode. Snapshots are one of Drop's main features and they are covered later in the video. If you don't want to use the clip launcher, you can use grid mode as a small MIDI keyboard instead. Therefore, select Notes mode. It's probably not the best keyboard in the world, but it's good enough to send a few notes here and there. The blue buttons now set the root note in the lower left in octaves or semitones. Below, you can select the target device and the channel. In the Bitwig extension, additionally, this channel must match in the settings. The scale lets you select or deselect notes, and the velocity sets the fixed value with which the notes are sent. Notes mode can also be used with standalone synths, which we will cover now. If Drop is to communicate with hardware devices, we need a completely different approach, because then all the mapping happens in Drop and not in the device. For synthesizers like this one, you will find a so-called MIDI table in the manual. This tells you which MIDI message you need to send to the synth to remotely control this or that parameter. The device therefore expects a very specific type of message, and it's in the sender's responsibility to send it as needed. When delivered from our lab, we ship Drop for the DAW initialized so that each control element sends a predefined MIDI message. However, for a hardware-based setup, it's best to start with a completely empty project. To do this, select Menu, Project, Clean Init. Now everything is dark, all control elements are deactivated and do not send any MIDI. The first step is to create the devices we want to use in Menu Devices. We can create up to 8 devices in each project, so right now we're in device number 1. I now activate the device with the small switch at the top and want to use it for our MIDI synthesizer warp. In the second line, I give it the appropriate name. You can assign a name here using the encoder and the colored buttons. But here's the tip. You can also connect the USB keyboard to Drop and type in names much faster. You can navigate through the menus very quickly using the arrow keys Enter, Escape and Return. In the play view, the MIDI traffic light shows 2 blue arrows when the keyboard has been recognized. You can also select the keyboard layout in the settings. Not only you can name the devices, but later on you can also give each control element and each snapshot a name so that you can easily find your way around your project. Back to creating devices. In the next line, you can now select the default MIDI channel for the device. Later, you can decide whether a control element sends to the default channel or any other channel from 1 to 16. You are not restricted to the default channel, it is just convenient to have it. Synthesizers often listen to only one MIDI channel, which you must also set on the synthesizer itself to the same channel you set on drop. Grooveboxes and drum machines often use several MIDI channels simultaneously. For such devices, it is best to select the most frequently used MIDI channel, or in the case of the electrons, a global channel. Next, we determine the port for outgoing MIDI messages. I use one of the included TRS cables to connect TRS1 output of drop to the MIDI input of warp-X. Warp can only receive MIDI, therefore I use TRS1 as the output and leave the input empty. Now let's create the octatrack as another device. I switch to device 2, activate it, and assign it a short name again. I use channel 16 as the default channel, which is the global channel on my octatrack. The octatrack can both receive MIDI and send MIDI back when turning its knobs. Therefore, I set the output and the input port and also connect two cables for MIDI in and out. Now I also want to connect the small MIDI keyboard via USB. The output remains empty and I only set USB as the input because the keyboard can only send data to us but not receive it. When connecting the keyboard, a green checkmark appears here, telling us that the connection is OK and that the connected device supports class-compliant MIDI. Most USB MIDI devices are class-compliant nowadays, but there are a few exceptions. If your device is not class-compliant, you will see an error message. Being not class-compliant means that the device needs a driver to be installed on your computer's operating system. In this case, you will need to use MIDI TRS, which is also fine. Back to our keyboard. Drop also supplies power to the keyboard via USB, and in the play view, the traffic data arrows are no longer grayed out, but light gray. When I press a key on the keyboard, I can see that MIDI data is coming in here. We also see a small flash symbol that tells us that Drop is now the USB host and is supplying power to the keyboard device. Please note that power supply is only possible if you operate Drop itself via the power supply unit. Back in the device menu, with USB connected, we can now also select a subport. And don't worry if you never heard about a subport before. A subport is the USB equivalent of multiple DIN MIDI checks. Most devices only have a single MIDI out and a single MIDI in socket, which in USB MIDI would be one subport for the output and one for the input. The MIDI keyboard, however, offers three subports. Well, on the one hand, the small keyboard has the keys, but it can also be used as a MIDI CV interface, and it also has a connection for an expander over here. So there are basically three independent functions combined in one small device. And if there was not USB, the manufacturer would have installed 3 DIN MIDI sockets for that. But over USB, they can emulate the 3 sockets, which is why we have 3 subports to choose from here. One takes the input from the keys, one is for the MIDI CV interface, and one for the expander. Another good example is the Oxy1. It is a multi-track sequencer that, by default, only has one MIDI output jack. However, there is an extension that turns this into 3 physical jacks, so when using USB instead of TRS, the Oxy offers virtual output jacks similar to having multiple DIN or TRS jacks. However, it appears that the Oxy offers only 2 virtual output jacks over USB, so in Drop we can only select 2 subports. Testing shows that subport 1 corresponds to output jack A and subport 2 to jack B. If you can choose to connect your device over USB or TRS, at first sight USB seems to be the better choice, as it is more modern and the data rate is 16 times higher than with a classic connection. But actually, the timing and clock precision is better with TRS than with USB. Unless you need to transmit tons of data, TRS MIDI is completely sufficient in practice. We also recommend connecting each device to its own TRS port in a star configuration to take advantage of the full data rate and best timing per device. Another feature of Drop is MIDI routing within the connected devices. Here we have the Oxy sequencer and the small keyboard, and we want to forward their MIDI notes together with the control messages from Drop to Warp. Combining MIDI data from multiple sources into one data stream is also known as MIDI merging. To set this up in Drop, I select my receiver device in Menu Devices, in this case Warp, and scroll down until I reach the merger settings on the 4th page. There are a total of 4 merger instances per device, so each device can receive MIDI data from up to 4 other devices. And now activate Merger 1. As the input source, I select the Oxy. I have a sequencer track set up in the Oxy that sends the data for Warp on channel 14. Therefore, I deactivate all channels except channel 14 under Listen to Channels. This can be done a little faster by switching to channel 14, holding down Shift and then pressing the encoder. I do not necessarily need to deactivate all other channels, as Warp would only react to channel 14 anyways. But by doing so, I filter out all messages that aren't meant for Warp and keep the line free for only relevant MIDI data. This is generally good practice and can potentially improve responsiveness if Oxy sends a lot of other MIDI data to Drop. On the next page, I can go one step further and even filter out certain MIDI message types. In this setup, I only want to process notes, pitch bend, and aftertouch, saving Warp from other unnecessary messages that Oxy might send. Under Target Channel, I can let the merger change the channel of the outgoing MIDI message to a different one. This means that the MIDI channel of Oxy's sequencer track and the MIDI channel of Warp don't necessarily need to be the same, because Drop can change the channel number. This can also be used for a scenario where you want to squeeze incoming MIDI messages from different channels together into one target channel. Of course, there is also an option so that Drop leaves the messages channel as it is and doesn't change it at all. Now I also want Warp to be able to receive notes from the MIDI keyboard in addition to Oxy. To do this, I activate another merger instance. I select the keyboard as the input. However, I'm not sure which channel it is currently transmitting on and what kind of messages it sends in addition to the notes, because this keyboard can be heavily customized with an editor. Out of laziness, I could simply leave all channels activated and also allow all message types on the next page, and simply trust Warp to ignore all unnecessary data. But on the other hand, the keyboard could accidentally send some messages that unintentionally change some parameters in Warp. So it is good practice to have a look at the MIDI data from the keyboard, and Drop offers a simple way to see exactly what's going on. In the play view, I scroll all the way to the right, where there is a MIDI monitor for displaying a history of incoming and outgoing data. At the bottom, I can select the port I want to monitor, in this case USB 2, where the keyboard is connected. At the top left, I can also switch between monitoring input or output. When I now press the keyboard, I see the data coming into Drop. Using the button at the top right, I can pause the live recording and scroll back through the history. We can see that a Note On event came in, followed by a whole series of aftertouch messages for the key press, but also CC number 1 messages, which in this case indicate the finger position on the key. Finally, a Note Off message came in when I released the key. I also see that all messages were channel 1. I now switch back to the merger, tell it that it only needs to listen to channel 1, and filter out everything except notes and aftertouch. Even though Warp could use the finger position CC message, I don't want to use it in the setup because the keyboard is a little tricky to play anyways. Also for the second merger instance, I double checked that the target channel is set correctly. So we have now set up the merging and can use the keyboard in parallel with the Oxy one to play a few notes on top in Warp. We have now set up our devices and can start mapping, which means assigning the control elements of Drop to the parameters of the connected machines. To do this, we switch to Menu, Mapping, and then turn, press or move the control element we want to assign. I want to start assigning this rotary encoder to the cutoff frequency of Warp's low-pass filter. and activate it with the active switch. Let's change the color and assign a name. Below that, I can adjust the sensitivity to determine whether the encoder responds quickly, slowly, or at medium speed to my rotation. I can also choose different types of LED styles to best suit my control parameter. Filter cutoff frequency is unipolar, so I simply want the LEDs to be a line starting from the left. Further below, I can now assign a MIDI message. More specifically, there are 8 slots in each control element that can be used to send up to 8 MIDI messages simultaneously. I go with the first slot, activate it, and select one of the 8 possible target devices. You may notice that some devices show a warning symbol. This is because you have to choose a device that is activated and has a MIDI out port configured. The channel is set to default here, which corresponds to the channel we created in the device. I could also manually select a different channel here, but I will stick with the default. If I map several control elements to warp and later decide to change warp to a different channel, I only need to do it in the device and not in each control element individually. The same applies to MIDI port if I no longer want to run warp on TRS1 but on a different port. Further down, I can now set the message type and the message number. In addition to the usual CC messages, also 14-bit CC, NRPN, pitch bend, and aftertouch are available, and the buttons can also send note messages. A little spoiler at this point, snapshot buttons can also send up to 8 one-shot messages when executed, and they can also send bank and program change messages. The question now is what values we need to enter here to achieve the desired filter cutoff. The absolute old-school approach is to get our hands dirty and read the manual. Don't worry, I will show 2 more methods later that are more convenient, but let's go hardcore for now. So I open the warp manual and have a look at the MIDI table to see which MIDI message and which number we need to use to achieve the filter cutoff. And here it says it must be a CC message with number 13, so let's enter that. On the next page, we can now set the MIDI output value range and select from different curves. For MIDI CC messages, the range goes from 0 to 127. Holding Shift while turning the encoder changes the step size. Holding Shift and pushing the encoder switches between common values. There is a variety of different curves available. The last available option is Relative, a mode in which a MIDI controller sends incremental changes rather than fixed absolute values. Relative MIDI mode is often used for parameters such as tempo adjustment, scrolling through a list, or DJ turntable emulation. You can use the Invert button to flip the curve. Let's see it in action. Let's now use the same knob to send a second MIDI value to another destination. So I would also like to control the high-pass filter. To do this, I go to the next slot and also activate it. I have again selected warp with the default channel as the destination, but now I select CC number 17. According to warp's manual, this corresponds to the high-pass filter cutoff frequency. When I now turn the controller, we see that both the high-pass and low-pass cutoff frequencies change. Since both move at the same time, we have created a bandpass filter. By changing the curves, I can also create a DJ-style high-pass or low-pass filter. To make it look right, I also changed the LED style to match our new bipolar behavior. It would also be nice if we could reach the middle position more easily. We can use the push function for this. So I press the encoder, and now what the display shows is the settings of the push function. Also, the blinking LED shows the element that is currently being edited. With the rotary push function, I can also choose from different behaviors. Toggle and temporary are two modes that act as normal MIDI button, and we can also create up to 8 MIDI destinations here. Then there are a few modes that do not send MIDI, but affect the rotary encoder. For example, quick turn. This makes the rotary encoder more sensitive as long as we hold it down. There are a few reset functions that set the rotary encoder to the left, right, or middle position when pressed. Reset LR and RL switch back and forth between left and right, with LR favoring the left position first and RL favoring the right. This is helpful, for example, if you want to build a volume control and use the push like a mute toggle. For our high-pass, low-pass DJ style filter, however, I choose reset to mid. There are actually two other ways to do the mapping without looking it up in the manual. There is a fantastic open source database on the internet with MIDI CC and NRPN mappings for currently almost 200 devices. The database can be found at www.midi.guide. Drop already carries a copy of the database on its SD card when it's delivered, but you can update to the latest version at any time. To get the latest version, follow the link to GitHub and click on the green Code button. Then click on Download zip. You do not need an account to do this. I now unzip the downloaded folder and copy it as is to the root directory of Drop's SD card. And that's it. The files are sorted by manufacturer and are simply comma-separated CSV files, which, by the way, can also be edited with any spreadsheet editor. The table holds nothing more than the MIDI mapping table from the user manual in a machine and human-readable format. It's also possible to contribute your own table, if you are missing your favorite synth. To use the database, in the device menu I can assign a database file on the second page. I do this for Warp and the TB3. Now, back in the mapping menu, let's assign a few controls for the TB3. Let's use a new rotary encoder, set the color to amber, and activate the first slot. I select the TB3 as the target, and now a preset button has appeared at the top because we have assigned a database file. I can now simply select the parameters from a list here. I press the encoder and now have the opportunity to adjust a few things. Drop tries to derive a short name for the control element from the database. We can adjust the name here if necessary. The database also contains information whether it is a unipolar control from left to right or a plus-minus bipolar control with a center position. We can automatically transfer this to the LED ring here. I now confirm and we have mapped the parameter. The database entries are usually MIDI CC messages. However, some parameters can also be used with 14-bit CC or NRPN messages. If 14-bit CC is offered, you should use it. For example, oscillator tuning, where the usual CC resolution is not fine enough. A 14-bit CC message simply consists of 2 CC messages in a row, enabling a resolution of 16,384 steps instead of the usual 128, with only double the message length. Also, NRPN offers 14-bit resolution, but I would only recommend it if there is no alternative or if the higher 14-bit resolution is really needed. If NRPN is offered next to CC, there is often no noticeable advantage over CC messages, but NRPN consumes 3 or 4 times as much data. Now I want to map a few more of the TB3's knobs. To do so, I copy and paste the first rotary encoder a few times. Then, using the database presets, I assign different parameter mappings to the newly added control elements. Taking over the preset values sets different MIDI message numbers, but also assigns short name. Using the move function, I can rearrange the control elements the same way they are laid out on the actual device. Let's try it out. The third and probably most convenient option for mapping is to use MIDI Learn and Drop. I have now connected the Octatrack, which I want to use as a sampler, but also as an audio mixer for the 2 synths. The same process applies to other grooveboxes, samplers and drum machines. I now want to map 2 faders here as volume controls for Warp and TB3. A prerequisite for MIDI Learn is that the Octatrack also sends MIDI parameters when I turn the controls. You first have to activate this on the Octatrack and then plug the cable from the Octatrack MIDI out into the MIDI input of Drop. I now select a new control element in the mapping, activate it, go to the first slot and press MIDI Learn. What we see now looks quite similar to the MIDI monitor. TRS3 input is already selected because that is what we have set as the input port in the Octatrack device. And we can now see that messages are also coming in here when we turn the controls. We now receive CC messages with channel number 6 and message number 46. I stop the live recording and simply select the latest message from the top. And the mapping is applied. I do the same with another fader for the TB3. We receive CC46 messages again, but this time on MIDI channel number 8, because the Octatrack uses a separate MIDI channel for each track, like many other grooveboxes. As you may have noticed, there is a feedback by MIDI in option in the mapping. With that option, you can move a control on the receiver device and send MIDI back to Drop, where the control element will follow. Although MIDI feedback is not part of the MIDI standard, it is common practice for devices and DAWs to send back the same type of MIDI message to which the parameter is mapped. This works really nicely for the Octatrack. Here I have mapped a rotary control to a bit crusher using slot 1 with a linear curve across the full value range. For MIDI feedback, I also select slot 1. Now, when I turn the control on the octa track, the knob also moves. When I turn the control on drop, it moves again on the octa track. Since the octa track uses endless encoders, there is no jumping value. Let's assign a second slot to another octa track parameter using MIDI learn. There is also a button on the last page that simply duplicates the current slot. Now the control element sets both parameters at the same time, but also the MIDI feedback from the bit crusher turns the drop control element, which in turn again changes the second parameter. So all three stay in sync. However, when we turn the second parameter on the octa track, there is no MIDI feedback because we assigned slot 1 in drop for feedback. Only as I change this to slot number 2, drop will use the second parameter as the feedback source. Also, be aware that incoming MIDI feedback uses a linear curve to change drop's control element. Therefore, the selected slot should also have a linear curve across the full range. Otherwise, you may experience jumping values when switching back and forth between drop and the other device. Enabling MIDI feedback is useful, but not always necessary. Let's try the same with the cutoff control of the TB3. First, the MIDI input of the TB3 must be enabled. Also, in the mapping of the cutoff rotary encoder, MIDI feedback must be set to slot 1. Turning the cutoff potentiometer on the TB3 changes the control on drop as expected. But when I first use the cutoff on drop and then use the cutoff on the TB3, there is an audible parameter jump. This occurs because the potentiometers do not physically move when the TB3 receives MIDI. There is also no value catch function on the TB3, so the potentiometer takes over immediately and creates the jumping value. Unfortunately, there is nothing drop can do about it, as the TB3, like many other synths, uses immediate value takeover for its potentiometers. To avoid jumps, the best you can do is not touching the mapped potentiometer on the device itself and use only drop's mapped control instead. You might ask, what about the non-motorized faders on drop? Well, let's try it. I use this fader to control the volume on the octa track normally. However, when changing the volume directly on the octa track, drop's fader obviously stays where it is. But there are two small arrow-shaped LEDs that tell me in which direction I must move the fader to pick up the value again. That way, there is no audible volume jump. Another way to create a mismatch between internal and physical fader values is to switch to layer B, where no faders are assigned currently, and move the fader there. Then, when I return to layer A, the position no longer matches and I need to catch the value again. If you want to avoid that and don't need the faders on layer B, you can set layer A's fader behavior like this. This way, the layer A fader is always present also on layer B. Warp receives MIDI notes from the Aux1 and our little keyboard here. We have already set up the MIDI merger in the devices for this purpose. I now want to have a mute button above its volume fader that only allows MIDI notes from the Aux and the keyboard to pass through when the button is active. Therefore, in the mapping menu, I set the color and set the behavior to toggle. The slots are deactivated, so the buttons do not send any MIDI messages. Now I change to Menu Devices, select Warp, and scroll down to the mergers. The first merger processes the MIDI notes coming in from the Aux1, and I now activate the Note Gate function here. In the line below, we can now link a control element, and I select the button I want to use as a mute. We can also select an inverted note gate, so that the notes either pass through when the note button is off or on, depending on what you find more logical. Right now, notes coming from Aux1 are blocked, but the notes from the MIDI keyboard still go through. So I go to the second merger instance that is used for the incoming keyboard notes and also enable the note gate here, linking the same button. Now it mutes the notes from both inputs. If I set the behavior to inverted, only for the keyboard merger, the button now selects either the Aux1 or the keyboard as note input. Back in the mapping, I can now see that two links are set for the button. By clicking on them, it sends me right to the merger menu. We can not only block but also transpose the incoming MIDI notes. I have now activated two more encoders here and the semitones and octave shift on the next page. We can also set a permanent transposition offset without further assignments. Down here, I can then assign a control element using the link function and select the previously activated rotary encoder. For the octave, I like ±2, and for the semitones ±6, since an octave consists of 12 semitones. I also apply the semitone mapping to the keyboard's merger. This way I can play the keyboard always in the same key. To optimize this even further, I can now adjust the LED display accordingly. For the octave control, I choose 5 steps, as there are 5 discrete values from -2 to +2. For the semitones, I choose 13 steps, matching the range from -6 to +6. Now it looks good visually, and as the icing on the cake, I map the encoder push to return to center. By applying the same semitone link also to the TB3 nodes merger, I built a global tuning control. This diagram provides an overview of the MIDI flow. In the top right, there is a keyboard and a sequencer serving as input devices. The incoming MIDI data travels through the blue lines to the MIDI mergers. The mergers can modify the MIDI channel and apply note gate, semitone, and octave shifting, which can also be linked to Drop's control elements. The merger's MIDI output data is then put together with the other MIDI data from regular MIDI mapped control elements. Finally, all that data goes out to the target synth as one single data stream. If you have been working on a project for a long time, it can happen that it becomes messy at some point. Eventually, gaps appear in the slots, or you have outdated settings in inactive control elements, or there are active control elements that no longer have any function. With the Project Purge function, you can clean up your project with a single click without affecting its functionality. Drop automatically checks for unused devices, closes gaps, removes unused control elements, resets unused slots to their default values, and closes gaps in slot allocation. MIDI can also be used for tempo synchronization between devices. Drop is ideal as a master clock to keep all devices in sync and has a start and stop button at the top. The flashing buttons and the play view show us that the clock is running and where we are in the cycle, here with a length of 8 bars total. To stop, you have to press Shift at the same time as a safety measure to not accidentally stop the whole show. You can access the clock menu via the Shift and clock buttons. The cursor always lands on the top line, where you can easily set the tempo in beats per minute. The two blue nudge buttons on the top allow you to temporarily increase or decrease the tempo if you need to beat match by ear, for example to play back-to-back with a DJ or a band. In the second line, you can choose whether Drop works only with its internal clock or follows an external source. With an external MIDI clock, you can choose, among other things, whether start and stop messages and song position messages are also taken into account. Song position messages are sent by some sequencers and DAWs when there is a beat jump. In the line below, you can select the MIDI device from which we receive the clock. Here you can only select devices that also have a MIDI input set. When Drop is synced to an external clock, it even takes phase into account. This means that it not only measures the tempo information, but also makes up for lost time in the event of sudden tempo changes. You can also synchronize drop to incoming CV clock at inputs 1 and 2. In the CV config menu, you can choose the clock type more specifically. CV1 is always the clock signal from which the tempo is read. And CV2 can optionally be interpreted as a start trigger or as a gate signal. There are differences in the precision of the clocks depending on the port type. In fact, clocking via USB has some jitter and tends to be less accurate. In Drop, TRS and CV clocks have the same precision with only little jitter. It is also quite normal for MIDI clocks that receivers and transmitters often display slightly different tempos visually but still play in sync. On the next page, we can now specify which ports we want to send MIDI clock to. MIDI clock messages are universal and cannot be addressed to a specific connected device. In other words, devices connected to the same MIDI cable listen to the same clock signal and therefore have the same clock delay. That's why the clock menu does not list our 8 devices, but instead the actual hardware ports. The checkmarks in the left column determine whether MIDI clock packets are sent, which only carry the tempo information. The middle column determines whether start, stop and continue messages are sent, which may start or stop the sequencer at the receiver. The right column determines whether we send song position messages during beat jumps, thereby causing the receiver to perform a beat jump within its pattern. This is only relevant for devices running their own internal sequencer, and also not all of them understand song position messages. As the default setting, Drop sends MIDI clock and start-stop messages on all its outputs. You can set clock delays to compensate for the different audio latencies of your devices. Clock delays can help if you notice that some devices or grooveboxes are always a little bit out of sync. Unless your device is purely analog, there will definitely be a short delay between an incoming MIDI message and the resulting sound. This is simply because the device needs a little bit of time to process. And if multiple devices are involved, like an external sequencer connected to a synth, you also have to take the whole chain into account. Assume we have 2 devices, A and B, with delay times of 10 milliseconds and 4 milliseconds. Without clock delays, there will be an audible difference of 6 milliseconds. However, if Drop's clock output adds these 6 milliseconds to device B, there will be no audible delay. This means that the clock on device B starts 6 milliseconds later. But unless you're playing notes by hand or do precise finger drumming, that's probably just fine. You can also use negative delay times so that both devices run in sync with Drop. It has one slight disadvantage though. After starting Drop's clock, both devices need to speed up initially to reach their target. Basically, it takes a few seconds after starting Drop's clock for everything to be in sync. This doesn't happen if you only use positive delay time values. In addition to milliseconds, you can also increase or decrease the clock delay by 1 clock packet. In our test, we only found one DAW that apparently ignores the first clock packet and therefore requires a -1 here. Usually, you would leave this value at 0, however. You adjust the clock delay by ear until it sounds right, which involves some trial and error. some devices, you may find a stop button prominently placed in the center. If you accidentally hit it during a performance, the internal sequencer will stop instantly and it is almost impossible to get it back into perfect sync manually. This is where the ReSync button comes in handy. It simply sends a stop and a start message to all devices in quick succession at the beginning of the next bar. It simply sends a stop and a start message to all devices in quick succession at the beginning of the next bar, creating an inaudible restart of all sequencers that are listening. Of course, this also takes into account the individual clock delays. Drop has two CV outputs that can generate voltages between 0 and 5 volts and also output clock signals. You can set the type of clock in Menu, CV Config, and apply the matching clock type for your receiving device. A 0 to 5 volt signal amplitude is the standard, but you can change the voltage range here if necessary. Or simply swap min and max for an inverted signal with falling edges. You can also select triggers and gates to start and stop an external sequencer. There is also the option of outputting a rising ramp that corresponds to the playback position within a cycle or within a bar. Jump and snapshot related voltages and triggers are also available. You can also simply link the CV outs as a variable voltage to one of the control elements. To do this, select Linked Control and use Set Link to select the desired control element. Further down, you can define the function of the CV inputs. Drop can synchronize its tempo to a clock signal on input CV1 and accepts two different clock speeds. CV2 can be used as a start trigger or play gate. Of course, you must also select CV input as the source in the clock menu. But there is also another way to use the CV inputs. You can also select and fire snapshots in jump mode using CV and gate. But let's have a look at snapshots first. Snapshots allow you to capture and recall the positions of the rotary knobs, buttons, and faders. I took a little leap forward in time and continued setting up the live set. Creating snapshots makes sense once you have mapped a few elements and have at least one loop running. Drop is now my main user interface for all the devices. I can access everything I need on a single user interface. We now have some rotary encoders that affect warp and cyan, some controls for the TB3 in orange, and here in magenta the kick drum, and some more percussion from Octatrack and Analog Rhythm in purple. Each of the 20 buttons here can contain a snapshot. There are also 20 banks, for a total of 400 snapshots per project. To save the current state as a snapshot, press the Save button and then the desired snapshot button. In an intermediate step, you can select the color and, very importantly, which control elements are actually saved in the snapshot. Everything that is green over here will be saved. If I turn this knob to the left, it turns red and will not be included in the snapshot. If I turn it to the right, it is included again. It works the same way when pressing buttons or moving faders. And not to forget, this also applies to layer B. To save a snapshot, I simply press one of the 3 snapshot buttons here. So now we have saved the state of all the controls in that snapshot. I can revert to that state by simply pressing the snapshot button anytime. Now I only want to save a snapshot containing the parameters of warp without the other control elements. To do this, I press save again, and now I have to deselect all the control elements that do not affect warp. And this takes a little while. It's faster if I use the selection groups up here. There are 8 groups available and I'm switching to the second group now. Initially, the group is empty because we started the project with a clean init, so all the control elements are red. I now select all the controls that belong to warp. Then I can also set a color here. All snapshots that I create from this selection group will get this color assigned. And by pressing a free snapshot button, it will save it. I will now use the same selection group to create a few more snapshots containing warp. I can now switch back and forth between them, and only the warp parameters change. In the meantime, I've also created a few more selection groups, one for the TB3, one for the percussion, and one just for the kick. And there is also the first group, which I have set to affect all the control elements. From now on, it is very fast to save a snapshot on the go by just picking the group and hitting a snapshot button. I have now created several snapshots per group, which allows me to completely change the individual parts at the touch of a button. You can execute snapshots in 2 ways, jump mode or drop mode. Currently, we are already in jump mode, indicated by the blue button here. A jump means that the snapshot is executed as soon as you press the button. On the third page of the play view, you can also set quantization for jump snapshots. With the potentiometer at the top, you can also set a variable fade time. In the beat jump view, you can see how long the jump will last, and you can also change the remaining fade time while it is running. Even when I am in a different menu, I can still see the cycle buttons flashing blue and always have an idea of what's happening currently. I can also run multiple snapshots simultaneously. If a control element is moved by 2 snapshots simultaneously, the one that was pressed last takes priority. I can end all jumps at once by pressing the jump button again. The maximum jump length is a full cycle by default. You can also select fixed time values in 10-second increments up to 60 seconds. There is another option here that determines whether multiple snapshots are allowed at the same time or not. You can also fade manually by holding down Jump and then selecting one or more snapshots. The fade only starts when you turn the potentiometer all the way to the left. Now you can manually fade from the current state into the next snapshot. To exit manual fade, use the exit function here. There is also exit and return, which will take us back to the starting position. And then there's the drop mode. Here, the snapshot is only executed when the drop moment is reached, which is when the playback position has reached the top, which marks the end of the current cycle. In drop mode, snapshots are executed immediately without fade time. A drop can provide a safety net. You can get completely lost, and the drop takes it all back on safe ground. When using jump and drop at the same time, a drop always stops the jump. This makes it easy to create complex build-ups and transitions into the next scene. Drop is executed as a single event or repeatedly. Repeat mode allows me to play like this. We can also edit saved snapshots. To do this, I select Shift and Edit. Before I press a snapshot, I can choose whether I want to edit or delete it. I select Delete, and every snapshot I press from now on will be removed. But don't worry, when you re-enter edit mode later, you will have to actively select Delete again as a safety measure. When I keep Edit selected, the snapshot is executed immediately upon selection. so we can also hear what we are editing. Using the buttons below, I can now choose whether I want to change the selection of control elements or the actual values. The snapshot is also no longer related to the selection group that we used when saving it, so you can add or remove control elements from the selection as you like. I can change the color, or give the snapshot a name. Further down, things get exciting, because each snapshot can also send up to 8 one-shot MIDI messages itself. These messages are sent when the snapshot is executed. And when the snapshot is fired in a drop, the messages are also sent out at the end of the last bar of the previous cycle. You can now also choose bank select and program change messages, allowing us to instruct a device to load a new preset or pattern. If we send a program change message to a machine running its own sequencer, this information must be received a little bit before the end of the old pattern. There is a setting per device for how much pre-delay is applied to program change and bank select messages. Some devices, such as Warp, always take about the same amount of time to load a new preset. Electron devices need a time specification relative to the tempo. We have found out that 3 16th notes work reliably, at least for Octatrack and Rhythm Mark I. Unfortunately, this information is usually not documented in a device manual, so you will have to experiment a little. However, there may also be some control elements that you want to be sent out before the end of the cycle. The classic examples are the mute, volume, and filter of the kick drum, which are typically used in dance music during the build-up and drop. Let's reduce the kick drum in the build-up. Next, I want to release the tension with a drop. And of course, I want that impact right on the first downbeat of the new cycle. So it must be 100% certain that the kick is already set back a little before the drop moment. And yes, there is a setting for that. So in the mapping menu, you can give the control elements a high priority flag. Then, when the snapshot is executed, the MIDI messages are sent in addition just before the other control elements and before the drop moment, just like MIDI messages from the snapshot button itself. I recommend to use the high priority setting only when really needed. With the chain function, you can string snapshots together as an arrangement. For this example, I have built some snapshots that affect all control elements at the same time. We can access chain mode by holding Shift and Chain. Within each project there are 20 chains in total. I can select the chain up here. I push Add, and now I can chain up to 64 snapshots, which are then executed in that order. Please note that only one snapshot is executed exclusively in chain mode. You cannot fire multiple snapshots at the same time. So in this column you can see the name of the snapshots, which by default consists of the bank number, X and Y coordinate. If you're building a live set with chains anyway, it's worth naming the snapshots now. You can choose whether a snapshot is triggered as a jump or a drop. In the next column, I can specify whether the cycle length should change after the snapshot. For a drop, this is the cycle duration that is set after the snapshot has been executed. For a jump, it is the fade time of the snapshot, which in chain mode is always automatically a full cycle. A dash means that we simply stay with the current cycle length and nothing changes. Stop means that the snapshot is still executed, but then the playback of the chain is interrupted. This allows you to divide the chain into sections and also continue from the middle. I can also insert pauses if I don't want anything to happen for one cycle. You can also reorder the list using the rightmost column. And there is also a delete function. I can also give the chain a name. Okay, let's play it. Purple flashing buttons indicate that a chain is currently being executed, even if you are in a different menu. The number of chains is 20, which is deliberately the same number as snapshot banks. In principle, you can also insert snapshots from other banks into a chain. However, it may also make sense to use only the snapshots from the same bank number in a chain. If you decide to link the bank and the chain, there is a little help in the settings. With chain to bank, you specify that when the chain is changed, the corresponding bank is also automatically selected. The other way around, with bank to chain, the corresponding chain is also selected each time the bank is changed. Please note that when switching chains, the chain playback is paused. There are several ways to remotely control drop via MIDI from external devices, and also to remotely execute snapshots. You can also synchronize two drop units in this way and link them to one large surface. A little warning in advance, you should only activate remote control if you really use it. If you have remote settings enabled, but you're not actively using the functions, unforeseen things can happen if the wrong message comes in, such as snapshots being executed out of nowhere. In this example, the TB3 plays notes from its internal sequencer and is processed by some effects of the octa track. All of the snapshots here affect the TB3's timbre. In the remote menu, there is a simple and fun mode for triggering snapshots via MIDI notes. I have set up the Oxy1 not to play notes on the TB3, but to remotely trigger the snapshots. Snapshots are picked by pitch, by velocity, or by random. The fade time of the potentiometer applies unless you have activated the no fade switch. Let's record this into a little sequence. Drop always uses the snapshots of the current bank in this relatively simple mode, but you can also get more in-depth access. We can activate additional remote control options. Among other things, this is also intended to link two drops together. Drop itself also has a MIDI mapping table. That means a scheme that allows you to remotely control certain functions via MIDI. You can find this in the manual. Also, when linking two drop units to each other, it uses that MIDI table for synchronization. In jam mode, you play with a bandmate who also has a drop. You both have your own equipment connected, for example, one plays drums and the other plays melodies. You just want your timing to be synchronized, which means the cycle length and the playback position within the cycle. Or in other words, when you execute a drop, it should happen at the same time in both setups. In this setup, each drop has set the other one as a device in the device menu. Here they are connected via USB, which also allows me to power one drop from the other. But two MIDI TRS cables would also work for synchronization. I configure the left unit as the sender with jam mode on default channel 16 and make sure that the target is the right unit. Vice versa, I set up the right one as the receiver, also in jam mode, listening to channel 16 and looking for incoming MIDI messages from the left unit. In addition, I have to configure clock synchronization in the clock menu. Clocking is independent from the remote control. Here I want to be the left unit the master clock. One side note here. When using remote control, it is important that we do not send song position messages between the two devices. So both drops should have the song position markers unchecked. That is because song position messages are used to transmit beat jump information, but the remote link function uses other MIDI messages for that. Now I start the clock and both start playing. If I now do a beat jump in the left drop, the right one follows. Also, if I change the cycle length in the left one, here too the right one does the same. However, if I beat jump on the right one, nothing happens on the left, because it's only the receiver. To change that, we can also enable the right one to be a sender and the left one to also be a receiver. Now it doesn't matter who does a beat jump, the timing is always synchronized and the drops come in at the same time. Besides jam mode, there is also dual mode, which goes one step further. This is the scenario when one drop is too small for you and you would like to be twice as big. Both units now share significantly more parameters, basically everything that concerns firing snapshots in the same style. For example, quantization and fade time are shared across both devices. When I turn the potentiometer, the fade time of the other drop follows and the LED starts flashing. If I want the left potentiometer to be in effect again, I have to cache the value. Some parameters are also shared now in the settings menu, such as the maximum jump time and if multiple snapshots are allowed to be executed in parallel or not. Finally, in full mode, snapshots are also executed synchronously across both devices, and the same layer is always displayed. You can also use full mode to synchronize drop from a DAW and have all options available. Since the receiver and transmitter can be different and have different sync levels, you can customize it for all possible scenarios.